All right, so let's see if we can actually build one of these for entertainment's sake. All right, let's somebody come up with what we want the right-hand side to look like, and then we'll try to come up with an expression that gives us that. What, sorry? All true? Well, that's easy. That's just the function that returns true. So that's you know, there are many things that are logically equivalent to that. So for example, P or not P. Right? That's always true. That's an example of something that has this truth table. Okay? All right. How about a harder one? True, false, true, false? Okay, so this is one that is true whenever Q is true, right? And it's false otherwise. It's true exactly when Q is true. So this is logically equivalent to Q. Right? It's a function of P and Q whose value is Q, whatever Q happens to be. How about another example? True, true, false, false is just P. Yep. How about true, false, false, true? Okay. This one has a name. All right. When is this true? This is true if both P and Q are true or if both P and Q are false, right? So we can write that as P and Q or not P and not Q. Yep.
It's either both of them or?
Neither. Both or neither. Yep. Okay. So this thing has that as its truth table. It's true if both P and Q are true. It's also true if both P and Q are false. But if only one of them is true, then both sides are going to be false. So it'll be false. Now this is actually the truth table for if and only if, which is written as a double arrow, like that. So this is the same thing as, this is logically equivalent to P if and only if Q. That's what its truth table looks like. That's what this means. That's what this symbol means. It translates to that. This is also equivalent to P implies Q and Q implies P. Sorry. And, not or. Yeah. What happened to not P and not Q? What do they look like? This one, this whole expression evaluates to this. Right? If we plug in true and true, we get that this is true, and therefore the whole expression is true because we have true or false, which is true. That gives us this line. Suppose P is true and Q is false, then P and Q is false. Not P and not Q is also false. We have false or false, which is false, so that gives us the false. Similarly here, these are both going to evaluate to false, and that'll give us false. But if they're both false, P and Q is false, not P and not Q is true, because that's true and true. Not false is true, and not false. So that's true and true. This evaluates to true. That gives us this row. Was that the question?
Also, you combine disjunction and conjunction for the function?
Yeah, this is sort of a complicated function of P and Q that only involves negation, disjunction, and conjunction.
Yeah.
And this is its truth table.
Okay.
Okay, it is one of the 16 possible truth tables.
So you combine, yeah.
Yep. Yes.
So, by definition, would that mean if P implies Q and then Q implies P as well?
Yeah. So this is saying that these are all logically equivalent things. So this is a truth table. This, if you like, is a definition of if and only if, a definition of this, the double arrow. It is defined to be that. Okay, that is its truth table. P, if and only if Q. Okay, and this is if P then Q and if Q then P has the same truth table. Let's look at that. So if P then Q, right, that's going to be true if, we can do two things at once here. One is we'll evaluate this by plugging in values. That's one way to try to evaluate a complex expression. Another way is to try to reduce it by putting in, by making substitutions that are identities. Okay, so what happens if P is true and Q is true? So that would evaluate to true implies true, and true implies true, right? Which evaluates to true and true, which evaluates to true. Right? So over here, it has the right value. When both P and Q are true, it's correct. What happens if P is true and Q is false? Then we have true implies false, and false implies true. True implies false is false. False implies true is true. False and true is false. So we get back this. Yes?
I don't need this back here, but is there a way to explain why false and true is false, or should we just memorize it as false and true is false?
Why false implies true?
No, at the very, like just false and true is false.
Oh, well, and means they both have to be true.
Right. Like for, well, some of them are like less intuitive and like kind of filtered.
It really is I mean, it's a definite. What does it mean for and? It is sunny and I'm wearing sandals. That is false. If it isn't sunny, it is false if I'm not wearing sandals. They both have to be true.